Okay, so now we're going to talk about confounding variables. So remember, confounding variables is anything that might mess up your experiment, anything that might cause the dependent variable that's not the independent variable, something that would change the results of the experiment without being the thing that you're trying to get to change the results. So the Hawthorne effect is a type of confounding variable and was named after an experiment done in the 1950s at the Hawthorne electric plant. So what they did, they tried to change the lighting in the electric plant to see if that would change the factory workers' productivity. So they had an experimental group, they had a control group. The experimental group got a different lighting condition than the control group. The control group just got the regular lighting condition, but I believe that they dimmed the lights for the experimental group, and then they had the people that were in charge of the experiment. It was their bosses. They had them walk around with little clipboards measuring their performance, measuring their productivity, and amazingly, not really, amazingly, both the experimental group and the control group were more productive. It didn't matter whether the lights were dimmer or whether they were getting the actual light that they typically get on an everyday basis. Both experimental and control groups had a report of higher productivity. Why would that be the case? Why would they both be more productive as their bosses were walking around measuring their productivity? It's because their bosses were walking around measuring their productivity. And so just the fact that you are in an experiment changes the results. The fact of being in an experiment is a confounding variable within itself. When you know you're part of an experiment, your activity, your behavior, what you say might change. And so whether the lights were brighter or dimmer in the electric plant, productivity went up just because they were that is a change of the dependent variable. That's not the independent variable. It didn't matter whether the lights were dimmer or brighter or the same. What mattered is that they were in the experiment themselves, and that's a confounding variable. That's called the Hawthorne effect. Other confounding variables is experimenter bias. If the experimenter knows who's getting the drug, the active ingredient drug, or the placebo, some sort of sugar pill that's not supposed to do anything, if the experimenter knows who's getting what, they might be a little bit more likely to treat people differently. Subconsciously, they don't know that they're doing it. But if I, know that this group is getting like the drug to cure cancer, and then this group is getting some sugar pill that's not going to do anything, I might ignore what they say. But the people that got the active ingredient, I might be like, hey, how you doing? I feel that you're going to do better today. Don't you feel better? And that, me treating them differently, would actually change the results. You might give people hope or take away hope just by the way of me treating them. So how do I get around that? It's not a conscious act, but how I get around that is a double-blind procedure, meaning neither the experimenter nor the people participating in the experiment know whether they are getting the independent variable or if they're getting some sort of placebo. They don't know if they are getting the active drug or some sort of sugar pill. Neither the people getting it nor the experimenter. So it is a double blind, meaning both the experimenter and the participants of the study are blind to what's actually happening. So there's not going to be any sort of bias one way or another. And we've said the word placebo before, but placebo is a non-active drug. It is, think of giving college students a non-alcoholic beer and then giving another group of college students a beer with alcohol in it and seeing how they interact. The people that got the non-alcoholic beer, that will be a placebo. If they were to start acting drunk, which studies have shown that if you are given college students, non-alcoholic beer, they will act drunk. That's the placebo effect. If you give someone a sugar pill and tell them to cure cancer, it's going to cure cancer, they might feel like they're getting better, even though they're not. And you know what? They might actually be getting better just because of a little bit of hope that they're getting better. That's the placebo effect. Another one is an order effect. the order in which you do the experiment might actually change the experiment, depending on what you're studying. So let's say that I have you memorize a list of words, and then I test your memory, and then I have you memorize a list of some similar words after doing exercise or something. I'm like trying to see if exercise increases your retention of vocabulary. And I have you, memorize a list of similar words. Well, just the fact that it's a similar words probably makes you retain that information a little bit more, whether you were doing exercise or not. So if you had a list of like farm animals that you had to memorize, and then I tested you on those, and then I made you do some exercise, and then I tested you on maybe like zoo animals as opposed to completely not animals at all. I tested you on zoo animals. You might remember the zoo animals a little bit more than the farm animals, just because I put you in the order of things, made you remember just animals to begin with. So that's a confounding variable in itself. So we try to get rid of the order, change up the order that you do things, or the placebo effect. You got to watch out for that, or you make sure there's no experimental bias with a double-blind procedure. Okay, let's talk about the idea of correlation versus causation. So I'm now switching kind of gears. A correlation, I'm going to actually see how much time we got here. Okay. There's a huge difference between correlation and causation. An experiment can show causation. Smoking causes cancer. This causes that. One will lead to the other. That's a causation. That can only be proven with an experiment. You cannot prove causation with a naturalistic observation, with a survey, or with a case study. You cannot do it. Only with an experiment, and only after repeated experiments, doing the experiment over and over and over again and replicating it, can you say that there's a causation. And so typically most studies are going to give you correlation, because most studies are not experiments. Most studies are surveys, or naturalistic observations, or case studies. Only, very infrequently are there experiments that actually have the weight to have a causation. So correlation expresses a relationship between variables, does not show causation. So, like this little picture right here says, did the AVAs cause the U.S. housing bubble? And so you see the housing price index, which measures house prices going up, and the amount of AVAs that were born. And you kind of see that those go together. But that's not, they're correlated. They're happening at the same time, but that does not mean that one is causing the other. And so it's kind of a joke between is it correlation or causation. Here's another thing that are correlated together: ice cream sales and murders in Houston, Texas. They are positively correlated. The more sale of ice cream, there's also a higher homicide rate in Houston. But it is not a causation. Ice cream sales do not cause people to be murdered. So how does it happen? Okay, well, the things that are happening at the same time, that's how they're related. Ice cream sales peak when it's hot outside during the summer. Also, during the summer when it's hot outside, heat causes people to be more aggressive. And so the fact that it's hot causes murders to go up, but it also causes the sale of ice cream to go up. So those are happening at the same time, but that does not mean one is causing the other. They are correlated, but they are not causing each other. Okay, and I said this kind of a little bit earlier. I said positive correlation. Well, there's positive correlation, or there's no correlation, or there's a negative correlation. And so a positive correlation, or a positive relationship between two variables, means that they go in the same direction. If more of this leads to more of that, and less of this leads to less of that. And you can actually see this on a graph right here. This is what the green line that sloped upwards, that is a positive relationship. Whatever is on the X and Y axis are positively related. More studying leads to more good grades. less of studying leads to less good grades. So they go in the same direction. They're directly related. A negative relationship still means that there's a relationship. It just means that there's a negative one, meaning more of one variable will lead to less of another. So like more alcohol will lead to less memory retention. Less alcohol will lead to more memory retention. That's a negative relationship. More of A leads to less of B, and less of A leads to more of B. So the variables are going in opposite directions. And you can show that with a negatively sloped line on a graph. Whatever's on the X and Y axis is going to be negatively related. And then if there is no relationship, like more or less of this does not affect any more of this or the other, that's just no relationship. And you see that as like a scatter plot on a graph. So there's this idea of a correlation coefficient. A statistical measure of the extent of which the two factors relate to one another. So how much is it positively correlated? How much is it negatively correlated? So the correlation coefficient is going to be some number between -1 and +1. -1 and +1. Negatives just means it's a negative relationship. Positives, it means it's a positive relationship. So a +1 would be a perfect positive relationship. -1 would be a perfect negative relationship. And then 0, if it's a 0, that means there's no relationship whatsoever. So the closest it is to either +1 or -1, the stronger that relation. The more this leads to this, the more that leads to this. The closer to 0, the more of its like chance. The more it's likely to chance, like there's, the murders and ice cream sales, that they're positively related, but that's not a strong relationship. It's not like a +1. It's not even going to be like a 0.9. It's probably going to be like a 0.4. So it's 0.4, it's positive 0.4, so it's a positive relationship. It's not a strong one. It's closer to 0 than it is to 1. So the plus or minus indicates the relationship, positive or negative, and then how close it is to either 0 or 1, positive or negative, indicates the strength. The closer it is to 1 or -1, the stronger the relationship. The closer it is to 0, the weaker it is. Okay. So you could probably get an idea of what the relationship is based on the lines of these graphs. So this is a -1. It's basically a straight negative sloping line versus a +1. It's really, really not scattered at all. I mean, you can draw basically a straight line between these points. These are kind of, clumped together, but it's sloped upwards, so it's a positive number, it's just not 1. And these are kind of clumped together, but sloping downwards, so it's a -0.94 in this example. This is no relationship. It goes up, down, there's no relationship here. And this is more of a scatter point. Look how close that is to 0. That is not close to -1 or +1, that is close to 0. And so it's a scatter plot. Okay. And we just said this. The number that it measures the strength of the relationship, the range is -1 to +1, and the relationship gets closer to, is weaker the closer it gets to 0. Okay. You can ask yourself, which one of these is stronger, -0.13 or +0.38? So for strength, we're not looking at positive and negatives. We're looking at how close it is to either -1 for a negative relationship or +1 for a positive relationship. And so plus 0.38 is closer to 1 than -0.13 is closer to -1. So that's going to be the stronger one. For the next one down, we have -0.72 or +0.59. It's going to be -0.72 because it's closer to -1. And for the third one, we have -0.91 or +0.04. Definitely it's going to be the -0.91 because that's really close to -1, and then 0.04 is so close to 0 that it's barely even correlated at all. Okay, so that's where we're stopping today, and we will be practicing the idea versus, negative versus positive relationships and correlation coefficients in class. right, thank you.